Now let's look at the architecture behind Cloud Composer. Cloud Composer is basically three technologies put together: Apache Airflow, combined with Google Kubernetes Engine, combined with Google Cloud Storage. Let's go through the role that each of these plays. As you already know, Airflow provides the software framework that Composer uses to define, schedule, and monitor workflows, which are represented as directed acyclic graphs, or DAGs. Next, Kubernetes Engine, or GKE. GKE clusters manage the containers that Composer runs Airflow in. So when we say that workers or nodes are added or subtracted to Cloud Composer, it is this cluster that they are added to or taken away from. Finally, Cloud Storage. Cloud Storage stores important data like DAG files, logs, and configuration files. Airflow reads from Cloud Storage, ensuring that your workflows and logs are kept outside of the runtime environment, which helps with reliability and scalability. This provides the persistent and scalable storage for Composer and workflow, and it does so outside of the environment itself, which makes the entire system more flexible. In summary, Airflow defines and manages the workflows, GKE handles the resource scaling, and Google Cloud Storage stores all the necessary files and logs. Let's talk about how exactly pipeline files are hosted for Composer and Airflow to use. Let's do this by first looking at a graphic. On the left, you'll see a Python file. This could be a pipeline task file or a DAG file. We're going to upload this file into the storage bucket that is automatically created by Composer upon environment creation, and it is dedicated to our Composer environment. Composer is automatically configured to look for files in this bucket. In fact, the bucket's name is always in a specific format, which you can see at the bottom of the graphic. Meanwhile, Composer is essentially constantly checking for updates to this bucket. So when we upload our file, it's immediately detected by Composer and ready to run if we want to. Every Composer environment gets its own dedicated bucket, automatically created when the environment itself is set up. Pipeline task files and DAGs are hosted in this bucket, and they are automatically read by Composer and Airflow. You don't need to manually tell Composer to look for the file. Composer is constantly checking the bucket for updates or new files. For example, if you have a prod Composer environment and you want to add code, you just need to copy the code into the prod storage bucket, and it would automatically be read. A situation like that could show up on the exam, so make sure you understand how this works. That's it on Composer's architecture and how it relies on Airflow, GKE, and cloud storage.